Okay, for the unit of sequences in Key Stage 3, we have 4 or 5 different type of questions, and the first one is finding the next terms when the sequence or the pattern is given to you. The ones I have selected are slightly different from the normal ones. So I'm going to be starting from 4. Okay guys, see what's happening. What is the common difference between these two terms? It is going down and it's by 3. It is going down and it's by 3 again. It is going down and it's by 3 again. So guys, we have reasonably okay to justify that this sequence, every term will be going down by 3. So we're looking at negative numbers. Negative 2 you standing at, you go down 3, that should give you negative 3, negative 4, negative 5, and go further down 3, that should give you negative 6, negative 7, negative 8. So these are the next two terms. Okay, but all the sequences, all the number patterns do not go up or down by the same number. There are many different ways. I cannot do all, but I'll start to some. Guys, what do you think is happening here? Sequence is going up. So going up means you're looking at either adding or multiplying. Let's see. So let's try both. Okay, let's see if we see a pattern. You add 1 to get 3. You add 2 to get 5. You add 3 to get 8. Looks like there is a pattern, people. 1, add 1, add 2, add 3. Let's see if that works for there as well. This is add 4. So that justifies that this will be add 5 to make it 17 and add 6 to make it 23. But if you observe it carefully, people, the second question has exactly same first 4 terms. Terms are the things you see at various places, but fifth term is different. So sequences or patterns which look exactly same might follow different rules there, guys. Have a look. So what happens here? Add 1, add 2, add 3, but then add 5. So that means this is not the pattern there. Something else is happening. Okay. So this is important. What you do is if you add 2 and 3, what do you get? 5. If you add 3 and 5, what you get is 8. So if you add 5 and 8, what do you get here is 13. So guys, the rule here is you add to previous terms to get new term or the next term. Right, so what will there be, guys? We're going to do 8 add 13, which is 21, then 21 add 13, which is 34. Okay, so what's happening? This is unique, guys. Pay attention what's happening here. You add 3, then you add 5, then you add 7, then you add 9. So there is a pattern there as well. So what do you think next will be? Add 3, add 2 more each time. Add 3, add 5, add 7, add 9. So this should be add 7, add 11, that is 36. Then it should be add 13, which is 49. Now, well done. Now you should be able to use your knowledge. These numbers, by the way, are special numbers. Take a second. 3, 2, 1. I'll tell you the answer, guys. These are the square numbers. So sometimes sequences uses the rule of some known factor numbers. This is 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, then it's 36. Okay, right. So this is the first type of questions. You'll be given some number patterns and you'll be expected to find the rule, which is called term to term rule. How does a sequence progress, okay, from one term to the other? Okay, we move on to do the second section now. One of the very important type of sequences we need to learn is called linear sequences. These are the ones which go up or down by same amount each time. Alright then guys, the first one is going up in ones, then 2, then 3, not same. This is completely different, it's not even linear. This is going up in 3s, then 5, not same. What about this? This one is going down in 3, so this is a linear sequence. And if the sequence is linear, guys, you can find a thing called position to term rule, which helps you to find any term after that, or this is also called the nth term. So I'm going to teach you how do we find nth term of linear sequences now. Alright guys, there you see 4 linear sequences. I have tried to make sure that they are linear. We're going to find the nth term. So guys, I'm going to tell you the steps. Let's try and understand the mechanical process behind it. Okay, what do you see? First of all, find the common difference or how the sequence is progressing. So sequence is doing what, guys? It is adding 4 each time. It is for this reason, people, your nth term will have 4n. Very simple. If this was adding 5, would have been 5n. If it's adding 6, would have been 6n. But this is not all. Okay, what you have to do is you have to find the second part of this formula. And how do you find this is very, very important. You say to yourself, I need to find a previous term. So what happens, people, as I'm going left to right, I'm adding 4 each time. So if I come back from right to left, I should take away 4. So 3 take away 4 is -1. So the nth term of the sequence is nth term, or position to term rule is 4n minus 1. Let us try this one, guys. What's happening in this? This is take away 5, take away 5, take away 5. So this is a linear sequence. The common difference is -5. So the formula will have -5 times n. 4n, by the way, algebra. You will be learning more about this algebra later on. So this is when number and letter written together is 4 times n. It's -5 times n there. Okay, we just don't show this multiplication sign in algebra. Right, guys, and then same process. This doesn't stop here. We're going to find the previous term. Right, as we going from left to right, we're taking away 5. So the opposite, inverse of take away 5 is add 5. So 24 add 5 is 29. So this will be -5n add 29 is the nth term. Right, guys, if you want now, you can pause the video and work out answers to these questions yourself. Find the nth term. They can check the answer with me. So I'm going to take a pause here, guys. I'm going to start writing answers in 3. If you want to do it yourself, pause it. 2 and 1. So let's have a look, people. This is add 2. That's a 2n. As simple as that. And the previous term will be 7 take away 2. 5 is a positive 5. It's 2n plus 5 is the final answer. Okay, this one, this is add 1.5, add 1.5, add 1.5. So 1.5n is the nth term's first part. Go back, find the previous term. So 6 take away 1.5 would be 4.5. There's a positive again. So 1.5n plus 4.5. These are the nth terms. Now, guys, why do we find nth terms? Why is this important? Because this is called position to term rule. I can now find any term for these sequences. This is first term, second term, third term, fourth term. If somebody asks me to find 18th term of this sequence, what do you think I need to do? I will just replace n by 18. So 4 times n's taken out of the team, 18 is substituted for it. 18 minus 1, which is 72 minus 1 is 71. So 71 will be the 18th term. That solves saves you from writing all the 18 terms and go up to 71. Okay, similarly, can we find 20th term for this? Can we find 40th term for this? And can we find 10th term for this, guys? Pause the video, work it out yourself. All you have to do is substitute n by 20, n by 40, n by 10 into it, then check the answer with me. Okay, so here are the answers then. We did 20, n equals 20, they put in here, get minus 71. I've got 85 in this for 40th term, and 10th term over here is 19.5. Guys, this is the advantage of position to term rule or nth term rule. Okay, we do a few more questions now. All right, so there's another advantage of finding the nth term is it will help you find if a particular number is going to be part of that number pattern or not, or sequence or not. So guys, this is fairly straightforward. You can use your common sense to this. This is a number pattern given to you. Somebody asks you, is 124 part of the sequence? What would you say? In 3, 2, and 1. I did this before and I had a clever soul telling me this will not be a part of this sequence, not doing anything. He just checked that all these part numbers of the sequence, all these members end up in 3 or 8. This ends up in 124. Brilliant, I like that. But if I come into this one, people, I won't be able to make that kind of a judgment. So if I say 36 is going to be a part of the sequence or not, what I'm going to do is I'm going to find the nth term of this sequence. Let's see. Okay, 2 add 3 is 5. Add 3 is 8, which is a 3n. Then find the previous term, which will be going opposite of adding 3. Take away 3 from 2 is minus 1. So that's the nth term. So I want to see if 36 is part of this or not, guys. I will make sure I solve that equation now. I equate this nth term to this term 36, which I'm testing. Now, guys, if you remember, cover this. Add 1, add 1. That gives you 3n equals 37. Divide by 3, divide by 3. N equals 37 divided by 3, which is not completely divisible. 37 is not a multiple of 3. So n is not a whole number. What does that mean? Guys, this implies that 36 is not a part of this pattern. Right, guys, the next type of questions you want to do when they give you the nth term and they ask you to find the first few terms, let's say first 4 terms of these sequences. Okay, we do some examples of that now. All right, for these type of questions, I've done 3 of them. They've given me 3 different nth terms. I have to find the first 4 terms of these sequences. Okay, guys, what does that mean? I'm going to be substituting n equals 1 for the first term. That gives me what? -2 times 1. I did say there's no sign between a number and a letter. That means they multiplied. Add 5. So it's -2 add 5. The answer is 3. N equals 2. I get -2 times 2. I just substitute n by 2 this time. Add 5. I get 1. So n equals 3. The third term, -2 add 3 equals 5, which is -1. Similarly, the fourth term would be -3. Okay, now can you try and do these two yourself to find the first 4 term? Remember, mind you, this is not a linear because this is n squared, but that doesn't matter. Once you know the nth term, you can find the first 4 or 5 terms if they ask you to. So do that, guys. I will do the answers in 3, 2, pause the video, work it out yourself, and 1. And here are the answers, guys. These are the answers, first 4 terms of this sequence, and these are the first 4 terms of this sequence. And like I said, this is not linear, and you can see this is going up in 3, then going up in 5, going up in 7, and so on and so forth. Not linear. Great, this is my first lesson on sequences, and we come on to some practical context sequences later when there's a pattern which are given as a diagram, they grow, and we're going to be finding out what the sequences are. Okay, I'll come with that video later. Happy learning, bye bye.